Good afternoon. It's still September 25th. If you've been following the other two videos I did this afternoon, or this morning, I should say, you realize that I'm sort of sketching out a curriculum. It may take place over quite a long time. You might use Scratch, MIT Scratch, for a year or two if you're going through elementary school, start second or third grade, use it in fourth and fifth grade, then around sixth grade, maybe you're interested in moving up to Python. The difficulty here, as I was describing, is you don't have the nice scope separation that we had. When we were playing with our sprites, we could easily tuck code in to each sprite individually, whereas in Codesters, it's a little more difficult to sort out which sprite is which. Here I've created two sprites. Let's just for fun create a third one in the Halloween section. I'll find a sprite. Let's see. I got to pick the sprites button. There's lots of persons. Let's get let's see. Let's get a broom. We had a witch already. I'm not sure if the broom makes much sense all by itself. Makes me think of Sorcerer's Apprentice and Mickey Mouse and all that and the Fantasia. Anyway, there we have three sprites being created, and as I pointed out, there's confusion here. I should make it clear that it's really the last sprite that takes over. In other words, we're binding the name sprite to first this particular sprite with Frankenstein as the name, and then we bind the name sprite to broom, so it forgets completely. The code does. Further down, the word sprite will from here forward mean the broom, except right away I name the witch sprite. So it's the most recent one that takes over. Now just creating them causes them to draw over here. I'm going to have Frankenstein go away and bring back the background and run this again. Let's keep the broom and the witch. But the broom, we want it off to the side a little bit, let's say at 150, and maybe down a little bit, maybe -20. So that's the Y or XY position that we want the broom to appear. Let's see how this works. So here comes the witch. There's her broom over there. She's also holding a broom, I now notice. So giving her an extra broom was maybe overkill. And there's all the pumpkins, and some of them turn into bats. Now what happens is I decide I don't even need to name these jack-o'-lanterns. I just go straight to appending them directly into a list called The Sprites. Starts out empty list on line 12, and then I start stuffing in these different sprites, or actually they're all jack-o'-lantern sprites, but they're each individual separate sprites. I just don't bother to give them a name. Instead, I compared it to putting eggs in an egg carton. You don't name them, but you do have the ability to iterate over them, and therefore make each one change size, make each one rotate by a random amount from 0 to 360 degrees. So that's what I get away with. Now let's jump ahead to a more adult environment. And let's look at this dog class. This again is a blueprint. You could think of it as a sprite. It's as if I had just typed the word sprite here. It would be like Codesters then. I would be then creating Codester sprites, kind of. There wouldn't be any graphics yet. I'd have to write all that because plain vanilla Python, it's not set up to do like little puppet shows the same way that Codesters is. But conceptually, it's very similar. The dog is kind of my blueprint for a dog, and then I'm going to create an empty list called dogs. And I use these open, closing square brackets to say, give me an empty list and name it dogs. And then like I'm doing with the jack-o'-lanterns and Codesters, you see the similarities, right? I am appending, instead of appending jack-o'-lanterns to the sprites, as I'm doing on line 16, in this case, I'm doing something very, very similar. I am appending dogs, individual dog instances, to the dogs list. dogs.append triggers the append method that all lists have, and it says add this dog to the list. Now when I call dog, and by call I mean I put these parentheses right after it, that's called calling dog, and I'm feeding in at the time a name for the dog. This is tantamount to triggering the birth method or the initialization method of the dog. All the dogs will share these little methods here. It's not like each dog instance has its own copy. They're all coming to the same place to check what do I do when I'm born. Well, I need to get a name and I need to remember it. Self.name equals name is saying I'm going to remember my name is Rover. My attribute as a self, as a dog self, is name. The attribute is called name, and it's going to be set to Rover, Fido, and Molly respectively. So then when I loop over this list, dogs, using any dog as my arbitrary name, I'm going to be able to pull out that name for each dog. Any dog in turn is going to bind to each of these dog instances or dog objects and suck the name out. I didn't really give the dogs independent variable names. Yes, they have the dog name like on a tag, Rover, Fido, Molly, but then they're just sitting there inside the list dogs without any real permanent name. But when I come along with any dog, I'm binding that name to each dog instance in turn, sucking out the name and then triggering the bark method on the dog and causing it to bark 5 times. So let's run this code. You can see it's already been run on the right. And there we have 3 different dogs, each barking. Now you can do a lot of work right here in this IDE, Spyder, without thinking that you're going to need to write programs that you use from Bash. Bash is a great place to trigger programs like we did last time. We were asking for the factors of 517 and so forth. But you don't have to write your Python programs to run in Bash. You can run them right here in Spyder. So this may be your main workbench where you get most of your work done. Then there's also Jupyter Notebooks, which we haven't gotten to. So let me quickly do that and show you what I mean by a Jupyter Notebook. It's another way to use Python. All this comes for free, by the way, in the Anaconda distribution. Not sure why the tile goes and hides there. I guess it's being a little bit shy. But what happens is a terminal window will pop up and automatically start running a web server. Here it comes. This is a little web server firing up right on my laptop here. And when it's running, it will also bring up a browser tab. Things are running a little slow because I've got Camtasia going and I'm doing all these things, so bear with me. Here we are inside the new tab, and I can dive down and say Discover Python, and that's just a folder. Here I have a bunch of my Jupyter Notebooks. For example, functions at work. I can pull up this Jupyter Notebook, and what it is kind of an alternation of 2 kinds of cell, and by cell I mean like a block. One kind is the markdown cell where you can compose text kind of like you're writing a book. So in the background you can use kind of a wiki-like language, a little bit of syntax to get the bullets and size the subheadings and get links, things like that. Markdown is quite simple. Shift Enter to evaluate. And then the other type of cell you'll have are called code cells. And here you are actually running Python, and you can actually change the code and rerun Python. So this is what Jupyter Notebooks looks like, and I recommend getting the Anaconda distribution if you don't have it, and giving this a whirl, trying this out. Now I get into some pretty interesting functions here, and I'd like to discuss them with you in another video. So this is where we're up to now. We've looked at Codesters, we've looked at Scratch before that, and now we're kind of diving into adult Python with various tools, both an IDE and a Jupyter Notebook. All right, we'll talk to you again soon.